Hello physical sciences learners, in this video we'll be looking at how to maximize your marks in a practical investigation or an experiment. So this is going to be a very general video. I'm going to go over what you can expect in a practical, the types of questions that pop up all the time that you need to know. I give some teacher tips on how to do the best that you can in your practical, so you don't want to miss anything in this video. Watch all the way to the end for those tips. Let's jump right in.
First of all, how many experiments or practical investigations do you do? You will be required to do 2 practicals as formal assessments. And that means that they count for marks. That means that they go on your reports. That means that they contribute towards your final end of year marks. And you will do more informal practicals to help improve your practical skills and help you practice. Those do not count for marks. So your teacher will definitely be clear whether it is a formal practical that counts for marks or an informal practical which does not count for marks. It's very important to pay attention and try and do well in both of these, because if you do well in the informal ones, you will improve your skills to do well in the formal assessments. So when do we do these practicals? You do them from grade 10 all the way to grade 12. For grade 10, the department recommends that you do practicals in term 2 and term 3. In grade 11 and 12, the department recommends that you do your practicals in term 1 and term 3. However, schools can, for example, for grade 10, do a practical in term 1 and then only record it in term 2. I hope that makes sense. But on our recording sheets, and I'm a teacher, I know about recording sheets, there's a space in term 2 and 3 in grade 10 for a prac, and a space in term 1 and 3 for a practical in grade 11 and grade 12. Now, each practical should be about 50 marks, and grade 10s, your practicals count 12.5% each towards your SBA mark. So remember that when you have your final mark at the end of the year, you have what is called an SBA mark, and your SBA mark is all the assessments and tests and exams that you do throughout the year. So like your term 1 test, your control test, your projects, your investigations, your assignments, your June exams, your September exams, all of those are your SBA marks. And in grade 10, your SBA marks are 40%, and then you'll write final exams in November, which is 60%. So basically, your experiments will each count 12.5% of the 40%. For grade 11s, they count 12.5% each towards your SBA mark. Okay, so same as grade 10s. Grade 12s, your practicals count a bit more. They count 15% each towards your SBA mark. So it's important that you do well in your practical. So how do you prepare for these? How do you study for them? What do you need to do to make sure you get the best marks possible? Well, first of all, I want you to make sure you know when your practical experiment is, or your investigation, so what dates, and on what topic it's on. Now, in a second, I'm going to show you the various topics, the prescribed experiments or practical investigations. These are the types of things that can be asked. Not all schools will do practicals or investigations on all of them. Your school will choose which ones to do practical experiments or investigations on. So let's say, for example, you're in grade 12. These are possible topics for practical investigations or experiments. And here are the possible topics for grade 11 and then for grade 10. So you need to make sure that you chat to your teacher and find out which topics your experiments will be on. And the reason for that is because the first important teacher tip that I can give you is to understand the theory behind your topic. So say, for example, you're in grade 11 and your practicals on Newton's second law of motion. You need to understand Newton's second law of motion. You need to understand what the relationships are between F net and acceleration, and F net and mass and acceleration, and truly understand what Newton's second law is. Now, I'm not saying you have to be able to do the most difficult types of theory calculations or the types that you would get in the exam, but you need to understand what Newton's second law is. Look at the definition, understand the topic, go over the theory, look at your textbooks. This, however, is so important in order to get top marks in your practicals or in your experiments. These are the types of scientific method questions that you can be asked. This is a very quick summary. I'm going to go over all of these now. This is basically the scientific method. We ask a question, we do a little bit of research, and we construct a hypothesis. And what I want to emphasize about this scientific method and practicals and what you will be doing is that when you get a practical, you will start off your practical. Your teacher must give you an aim. And from the aim of the practical, we can construct our investigative question. We can construct our hypothesis. We know what our variables are. We can draw up a conclusion. So it all links back to the aim they should give you in the beginning. So all of these, our investigative question, our hypothesis, our conclusion, they're all linked to the aim. So if you understand your aim and you can identify your variables from the aim, you will be able to construct a hypothesis as well as a conclusion. Now, I want to show you a basic biology example to help with this, because I think it's a bit easier to understand sometimes with a biology example. So let's pretend we want to test the following. Let's pretend that we have noticed that if we change the amount of sunlight, so the lighting conditions, the amount of sunlight, that looks like it might have an effect on plant height. So we've noticed this, we've made an observation, now we want to set up an experiment, but we need a question, we need an aim. So we're going to say the aim of our practical is to see how different levels of sunlight affect the height of plants, okay? So I hope you can hear what I'm saying. I'm saying different levels of sunlight affect the growth or the height of plants. So our variables in this experiment, there's two variables. One thing that we change and one thing that we measure. So what am I changing from here to here? I'm changing the amount of light or the light levels. Okay, so let's just say light levels or exposure to light or amount of sunlight or something like that. Let's say amount of sunlight. That is what I'm changing. So here I have very little sunlight. Here I have a lot of sunlight. And what am I measuring? I am measuring the height of plants. So I'm taking my ruler and I'm measuring the different heights. So I'm like, ooh, this one is 30 centimeters, but this one is 90 centimeters. So there's one variable I'm measuring, the one variable I'm changing. And when we set up an investigative question, we have to include both variables. Now, what's important about an investigative question is the following. It's a question, okay? It has to have a question mark. It cannot be a yes or no question. This is super, super, super important. And it must include both independent and dependent variables. We'll discuss what those are in a little bit more detail, but let's just take a look at what I mean by it cannot be a yes or no question. So, for example, you can't say, does more sunlight make plants grow taller? Okay, let me write that question for you. So what's wrong with this question? It has both independent and dependent variables. Remember, the independent variable, we'll go through this in more detail now, but it's the one that we change. So the amount of sunlight. And it has the dependent variable in, which is the one we measure. Plants grow taller, height of plants. So what's wrong with it? Why can't this be my investigative question? It's a question. Does more sunlight make plants grow taller? Always check to see if you can answer your question with yes or no. If you can, then it is not a good investigative question. So here we got, does more sunlight make plants grow taller? You can answer yes to that question and then you can leave it and you can be done. You can walk away and you're all good. But that means that it is a bad investigative question. So if you can answer yes or no, then it's a bad investigative question. Okay, so if you repeat the question, you should not answer with yes or no or one word. So, does more sunlight make plants grow taller? I can answer yes. That's a bad investigative question. So, these are all bad. Do plants grow better in sunlight? I can say yes to that. So, therefore, it's a bad question. Does sunlight affect plant growth? I can say yes to that. So, it's a bad question. Do plants grow better inside or outside? I can write a one-word answer to that. I can say outside. So it's a bad question. So you must not be able to answer it with yes or no or with one word. So here I answered these with yes or no, and here I answered with one word. Bad, bad, bad questions. So what would be a good investigative question? This one. How does sunlight affect plant growth? So do you see that if I had to give you this question, or if I had to ask you this question, you can't say yes. It doesn't make sense. You can't say no. It doesn't make sense. Get someone to ask you that question. How does sunlight affect plant growth? Can someone say yes? No, they can't answer like that. They actually have to explain. They have to say, as you increase the sunlight, plant growth increases. So you have to answer that question by mentioning your two variables once again. This is another way that we can write an investigative question, and this is how I always do it. What is the relationship between sunlight and plant growth? So I always tell my students to start off your investigative question with, what is the relationship between sunlight and plant growth or plant height? So that is how I start off my investigative questions. That's how I think you should start it off. So it's always, what is the relationship between, and then you mention both of your variables. So in this case, remember we discussed that sunlight was the thing that we are changing, which means it's independent. The plant growth or height is what we are measuring. So the one that we are changing, we change the amount of sunlight because we can put a plant on the windowsill, we can put a plant outside, we can put a plant in the cupboard. So I'm changing the amount of sunlight the plant gets. And then I am measuring the plant height. So the one that you are changing is independent. I remember it as independent, I change. Independent, I change. Dependent variable is what we measure. It's what we measure. And the dependent variable depends on the independent. So how high the plant gets, the measurement of the plant height depends on the amount of sunlight. Okay, there we go. So the independent is the values that I decide on before the experiment, and they determine what the dependent will be. So they affect the dependent. So I decide on the amount of sunlight before the experiment, therefore the amount of sunlight is my independent variable in this case. The dependent variable is what I am measuring, and in this case it's plant growth. Now remember, in an experiment we have one variable that we are changing. Okay, so we change it. Remember I said independent, I change, and one variable that we are measuring. You also have to have control or controlled variables. And these are things that can also affect the outcome of your experiment. And that's why they should be kept constant. So in the case of our plant experiment, I have to keep the wind the same, the soil type the same, the type of plant, the amount of water. I can't have one plant growing in the sun and one plant growing in the shade, and that is my independent. That's the thing that I'm changing, okay? The amount of sunlight. And I'm measuring plant height. But I can't decide to now go and give this plant all the water that I want, and this plant, no water. Then there's going to be two things that affect plant height. So all the other stuff, the water, the soil, all of that stuff needs to be kept the same. So once we have observed something, we've constructed an investigative question, we've done a little bit of research, we can then construct a hypothesis. And you should be familiar with a hypothesis. A lot of my students say, ma'am, a hypothesis is an educated guess. It basically is. A hypothesis is a logical prediction about what you think will happen, and it's based off of your aim. So we base our hypothesis on our aim. So if our aim is to determine or to see what the relationship is between amount of sunlight or levels of sunlight and plant growth, our hypothesis must include both of these variables. It's a statement. It doesn't need to be correct. So for example, if you had to say, as I increase the amount of sunlight that a plant receives, plant growth or plant height decreases, that doesn't seem like it'll be right, but for our hypothesis, it doesn't need to be correct. It's just a statement. It's a logical statement, a logical prediction, and it must include both variables. So the dependent and the independent variables. It has to include both. So in terms of our plant example, our hypothesis could be plants will grow taller. So plants will grow taller or will grow to a greater height, or you can mention height or something, when placed in higher levels of sunlight. So you are mentioning both your variables there. You're mentioning your dependent variable, so they will grow taller, the thing we measure, when placed in higher levels of sunlight, the independent variable which we change. We then construct our experiments and we collect our data or our data, and that gives us results. And from the results, we can draw graphs, we can look at tables, we can look for relationships. So for example, you might find a direct proportion relationship or an inversely proportional relationship, and you should be familiar with these. And from that, we can either accept or reject our hypothesis. We can summarize our results by writing a conclusion. Now, please, once again, remember what I told you guys earlier. Everything can be connected back to your aim. Everything. So in your aim, they mention 2 variables. In your investigative question, you mention 2 variables. In your hypothesis, you mention 2 variables. In your conclusion, you're basically stating what happened, but you need to mention both variables. But you also summarize your results. So for example, you could say, as I expose the plant to higher levels of sunlight, or as the plant is placed in more sunlight, the plant growth increases, or the plant height increases. So you're mentioning both variables. You're mentioning higher levels of sunlight, which is your independent variable, and you're mentioning plant height, which is your dependent variable. Very, very important. So let's look at a quick example. In grade 11, you do a Newton's second law practical, and the aim of the practical. So I took this from a practical for Newton's second law. We give you the aim. It's given to you by your teachers. In the prac, it says using a ticket timer to investigate the relationship between net force and acceleration for a constant mass. So from the aim, you can already identify your variables. Relationship between net force and acceleration. And your teacher will explain the investigation. So say, for example, I have a ticket timer. It's connected to a tape, and there's a little ticket timer, and it pulls through the ticket timer, and this is connected to a pulley, and there's a downwards force acting on this pulley. I can increase the force pulling this downwards. So I increase the weight on here, which increases the force pulling it downwards. So I increase the force. And then we are going to investigate what happens to acceleration. So what are we doing? We're keeping the mass the same, constant mass. So that's my control or my controlled variable. Remember, you have independent variable, dependent, and controlled variables. So in this experiment, I'm keeping the mass constant. So the total mass of the system. I know I said I'm increasing these mass pieces over here, but I'll cover this in another video. I'm keeping the mass of the system constant, but I'm increasing the net force. So this downwards force over here, that's pulling the trolley this way, I'm increasing the net force. So I am changing the net force. So which variable would that be? I am changing independence. And then I'm measuring the acceleration of the trolley. And you can do that by using the ticket timer, measuring the distances, measuring the times. But the point is I am measuring acceleration. So that's the dependent variable. So here I summarize it on this side. So the net force, we change the net force. We measure acceleration. So can you see from your aim, you've got both your variables. And from that, we can construct our investigative question. What is the relationship between net force and acceleration for a constant mass? So basically, when you're going to make your investigative question for me, you're going to say, what is the relationship between? You're going to mention your independent variable. And then you're going to mention your dependent variable, always. And if anything must stay constant, you may as well mention it in your investigative question as well. And there must be a question mark. Then remember, after that, you write your hypothesis. If the net force increases, acceleration of the trolley will increase if mass is kept constant. And you should know, if you know Newton's second law of motion, you should know that that is Newton's second law of motion. If I increase the net force, the acceleration will increase. They are directly proportional if mass is constant. So we're just basically doing an experiment to verify that. So that is basically how we use the scientific method and how you need to use the scientific method in your practicals. Now, what other types of questions can you be asked? So these are other types of questions that they can ask you in your prac. You have to know about your safety precautions. It is extremely important to take the correct precautions and know the rules of your lab. And we'll get into that in a second. They can also ask you, why do we repeat the experiment? Why do we do more than one trial? So often with experiments, we might, so say for example, we do the plant experiment. We might do one plant outside, one plant on the windowsill, and one plant inside. And we let them grow for a week. Then we take our our measurements, then we repeat the experiment again. They can ask you, why do we do this? They'll also ask you why your results may differ from what you expect, or discuss things that can negatively influence the experiment or the investigation and how we can fix it. So what can we do to minimize or to make the effects less, and how can we improve the experiment? They will probably ask you about safety precautions to take in a lab. Obviously, if they ask you for safety precautions, try and make it relevant to your practical. So, for example, you won't necessarily wear gloves, because I have gloves here. You won't necessarily wear gloves unless you work with chemicals. Same thing with masks. So if it's a chemistry experiment, you can mention wearing goggles, gloves, masks. But certain things are true for any experiment. Like, don't wear loose hair or clothing because it could get stuck in certain apparatus things. Do not run in the lab. Do not eat in the lab. So these are just a list of rules and safety precautions or lab safety rules that you need to follow. If they ask you, why is the experiment performed more than once? Why do we do multiple trials? It's because we want to increase the reliability of your results. I know students often say to increase the validity, to make it more valid. That's fine. We just want to make our results more reliable. If they say, why do your results differ from what you expected? You need to think about the particular scenario that you're doing. So for example, in a Newton's experiment, we might not get what we expect because if I have a ticker timer, we angle the ramp to compensate for friction. In other words, to get rid of the effects of friction. But we might not angle it correctly. We might not have gotten rid of friction in this experiment. Or there might be friction in the pulley system. Or the rope, the mass of the rope may have come into play. All these factors could influence the results negatively, and we might not see the relationship that we expect. So you need to think about this in terms of your experiment. I know when I do this with the grade 10s, we do a boiling water practical, and everyone knows that water should boil at around 100 degrees Celsius, but sometimes they don't get that. Sometimes they get 97 degrees Celsius as the boiling point. And one of the reasons, or they could get higher, one of the reasons why the water might not boil at 100 degrees Celsius like we expect is because of the impurities in the water. Maybe there's ions or chemicals in the water that affect the boiling point. So you need to really think out of the box. You might need to Google it, and that would be a really, really good teacher tip for me. Just Google it. If you know your practicals on Newton's second law and using a ticker timer, Google, why may a ticker timer not give me the results that I want or expect? Why, if I boil water, does it not boil at 100 degrees? So you need to think about it. You need to do some research. Do all of that before going into your prac. So there I wrote here, it depends on the experiment. You need to think about it, do some research. Ask your teacher what theory questions you need to know for your prac. They might give you some hints. They might tell you what definitions you should go and study. They might tell you, look up this, or you need to know Newton's second law, so look up all the theory, and then actually go and study the theory, grade 10s, 11s, and 12s. Ask your teacher for some application questions. So in certain practicals, you might do all the prac related stuff, and then they might throw in an application question where you have to actually do calculations. Ask your teacher if that will be the case, and if so, then just go practice some. Google your practical. I cannot emphasize this enough. If you Google grade 12 physical sciences practicals, grade 12 physical sciences experiments, you can throw in the keyword South Africa, you can throw in the keyword CAPS. Look at all the PDFs uploaded on the internet. There are learner's guides. There are even some teacher guides, and they can show you the types of questions that they can ask you in the prac. And if you look carefully enough and if you look hard enough, you can even find some memos that can help you. Seeing how practical questions are asked is very, very important so that you can get used to it, so that when your practical comes, you know exactly what to do. Other tips that I would add that aren't necessarily on this list is if you need to do group work, make sure you choose your groups nicely. Make sure you choose your groups correctly. Don't just choose your friends so that you can have a lot of fun. Choose people who are serious and who will get the job done. But my biggest tip is this. Google your practical. Some practicals exist on the internet and your teacher or your school might just adapt it slightly. I hope that this has helped you with how to prepare for a practical. And if you would like me to do a video on any practical in particular, please comment down below. Let me know. Obviously, the more comments I see for certain videos, the more likely I will be to make a video on that. But I hope that this has been helpful, and I'll see you guys in another video soon. Please don't forget to subscribe for more physics. Bye, everybody.